Well, ladies and gentlemen, good morning, and thanks so much for being here at this Warriors Corner, and more importantly, thanks for being part of the Maneuver Conference. My name is Jeff Norman, and I'm the director for the Next Generation Combat Vehicle Cross-Functional Team. That's quite a mouthful, but I'm part of Army Futures Command, but used to be a part of the Maneuver Center of Excellence in a previous life, and so it's fun to be home. And it's fun to see a lot of familiar faces here in the crowd, so thanks for being part of this morning. What I wanted to do over the course of the next few minutes is lay out for you what it is that your next generation combat vehicle cross-functional team is working on, how you can interact with us, and then where we're going in the future. So first I need to lay out sort of the context for what the cross-functional team is, what some of the other ones are, to sort of pull the thread that both the chief and the secretary laid out this morning. So we go to the next slide, please, Ruben. So the NGCV-CFT is one of 8 cross-functional teams. As the chief mentioned, there are 6 modernization priorities: soldier lethality, long-range precision fires, the network, air and missile defense, next-gen combat vehicles. So there are 6 modernization priorities. Each of those has a cross-functional team. And then there are 2 overarching cross-functional teams, one for the synthetic training environment and one for assured position, navigation, and timing in space, AP&T. And those have equities across all 6 modernization priorities. So overall, 8 cross-functional teams. We're one of those. One of the things that's unique about our cross-functional team is we're not located in the same spot as the Center of Excellence, in this case, MCoE. We initially were established here at Benning, but then quickly moved up to Warren, Michigan, to Detroit Arsenal, so we could be co-located with the industry partners in the program executive offices for those who are working on combat vehicles. So we're up there with PEO Ground Combat Systems. We're up there with the Ground Vehicle Systems Center, the organization that used to be known as TARDEC. And most importantly, we're up there at sort of the hub of automotive and ground vehicle innovation in America. So the role of the cross-functional team is to bring together a number of disparate organizations that normally work together to get a new capability for the Army, and in our case, combat vehicles. As was the case in days past, you would have a Intel analyst or a set of Intel analysts would identify a threat or an adversary capability and alert the community that the adversary is able to do something new. And then there might be a capability manager who would look at that threat and say, I don't have a capability to mitigate that threat, so now I have a gap. And then you would have a requirements developer who would write a requirement to deal with that threat, and then that requirement would get passed over to the science and technology person to work on the capabilities, the technology that needed to be developed or the invention that needed to occur to meet the requirement. And then if that magically occurred, it would go over to a program office to then become an Army effort that could be funded, and eventually something that could become a prototype that could be tested, that then could be put in soldiers' hands and eventually make it out to the field. Even saying all of that makes my head hurt, and it takes a while. But in reality, that took normally about 15 years. If you look at the time when the M1 tank or the M2 Bradley was fielded, to the time when it was actually initially envisioned or folks started working on those, it's about 15 years. What the cross-functional teams are tasked to do is to shorten that time span by working together, working in parallel with Intel analysts, capability developers, science and technology experts, inventors, industry, testers, and the program executive office and the program managers to smash all that together so we're doing collaborative work in order to reduce the time from an idea to the time that we can get something in soldiers' hands that they can start experimenting with and providing feedback to the Army so then we can get something useful fielded. So that's what the cross-functional team is all about. That's why we're up in Warren, Michigan. And the key for us is to stay tied in to the Maneuver Center of Excellence, and most importantly, to stay tied in to the operational force, the organizations like the 1st Armored Division, the 1st Cavalry Division, 10th Mountain Division, where Ruben's going to go next, various locations where we have war fighters who are trying to solve today's problems and can also visualize tomorrow's problems. Our goal is to get capabilities into their hands faster. And so we've been tasked to work on 4 principal systems, and I'll talk about those in a minute. But in reality, you know, we can talk about the big 5, as the chief mentioned in the past, Abrams, Bradley, you know, we go down the list of all of them. And you heard this discussion of a 31+4 or 24 systems that are going to be developed and fielded in fiscal year 23. What we're focused on is the next set of ground combat vehicles, some of which are going to be evolutions or transformations of current systems, potentially. Others are brand new vehicles. And then some others, it's yet to be seen which path we're going to go. Transform a current vehicle or invent new from whole cloth. So if we go to the next chart, you know, up on top, we know what we've got now. We've got the M1A2 SEP V3 tank, an incredible tank, capable of doing things that our adversary is unable to counter. It's a great tank, but it's also a heavy tank, and so there are concerns about its applicability in certain theaters, in certain environments. So that's something that we're taking a hard look at. The Bradley, off on the right there, has been around as described since 1980. We're now on the A4 variant. We're only getting a few brigade sets of Bradley A4. And just as the chief said and the secretary mentioned, we're going to be replacing the Bradley. The system that's going to replace Bradley is known as the Optionally Manned Fighting Vehicle. I'll talk about that more in the next chart. But on the bottom, as you can see kind of what we're going to, you can see that this new fighting vehicle, the Optionally Manned Fighting Vehicle, is probably going to be similar in appearance to the current Bradley, in that it's going to be a tracked vehicle with the turret. However, that's about where the similarities end. It's going to have all new architecture, likely going to have a remote turret and a whole host of things that are very different. But nevertheless, it's going to be a manned fighting vehicle that has the option to be operated either minimally manned or optionally manned in some instances. We're also introducing robotic combat vehicles to our formations, and it's not just the Armored Brigade combat teams, it's also the Stryker Brigades and IVCTs. Those are one of the important efforts that we're undertaking. And as was mentioned earlier, we're looking at the tank and what the future of the tank is and how we might be able to transform that moving into the future. So if we go to the next chart, I'll talk specifically about some of the things that we're working on. So building on Optionally Manned Fighting Vehicle. There have been several attempts to replace the Bradley over the years, whether it was part of future combat systems or the ground combat systems, ground combat vehicle, a number of attempts to replace the Bradley. And in most cases, those were unsuccessful. Well, in all cases, they were unsuccessful. The reasons they were unsuccessful varied, but we've taken the lessons learned from all of those efforts, and we're taking a very different approach now. The approach we're taking now is first and foremost to integrate soldiers early and often into the design and the requirements development for these vehicles. So some of you may have been part of that process. Some of you will be part of that process moving forward, but that's involved everything from soldier innovation workshops to virtual prototyping, where you're put in a digital twin of OMFV prototype, to soldier operational experiments where you're actually taken out in the field and you're operating in prototypes. We're not quite at that stage yet with the Optionally Manned Fighting Vehicle, but where we're going in the very near future is that by 1 November, industry is going to submit proposals, digital designs for the Optionally Manned Fighting Vehicle, and then a selection board is going to evaluate those against the characteristics that we've said are most important for a replacement for Bradley. We anticipate that we're going to get a whole host of designs from industry. Already in a previous effort that just preceded this one, there were 5 industry designs that were really impressive. They included things like composite rubber track, hybrid electric drive, new and innovative armor systems, integrated active protection systems, a whole host of capabilities that are going to be evaluated. But what we're anticipating doing is after those proposals come in, we're going to down select to 3 vendors and build up to 11 prototypes of each from each of those vendors. This is going to give us the ability to actually get soldiers in those vehicles and go out and do limited user tests with the Bradley replacement proposals. So 3 potential Bradley replacements that over the course of the next 18 months or so are going to get put through their paces. Initially through digital design reviews, and then subsequently by getting them out in the field, in the dust and in the mud. Right now, we're working on robotic combat vehicles, RCVs. We just finished up a 5-week soldier operational experiment at Fort Hood, Texas, with 1st Brigade, 1st Cav, and 1-7 Cav was the actual experimental unit. And they had the vehicle on the left, which is a medium variant, and then the one on the right, which is a light variant, along with a control vehicle, which was a modified Bradley that had robotic combat vehicle control stations in the back. They went out and put these vehicles through their paces in an operationally relevant environment. Initially doing cavalry squadron missions at the troop and platoon level. Initially did them without the robots, and then they integrated robots in various formations and in various methods to see what works best and what the priorities ought to be for robotic combat vehicles as we go forward. We've got great feedback from them, and they gave us some really interesting insights. And so we'll be able to spin those insights into the development of robotic combat vehicles going forward. But we're not waiting to let the perfect be the enemy of good enough. So this spring, we're taking those vehicles after they get refurbed, and we're going to send them back to 1-7 Cav, and they're going to continue to experiment as part of the Div Cav pilot for ForceCom, and they're going to keep iterating with robots, with both the control vehicles and the light variants to help us understand how they can employ those in the offense and in the defense and in the reconnaissance and security missions that they're challenged to execute. Get some great feedback, and some of the feedback that we're getting is that the controllers, the control interface for the robots that have been developed over the course of a number of years are really intuitive, and they actually wish that they had those interfaces on their combat vehicles right now. We're realizing that it's important that robots are used at the appropriate place at the appropriate time, and right now, using robots in the offense is a little more challenging than using them in the defense. And that has to do with rate of march and some of the network challenges for controlling how far we can be from a control vehicle to a robotic vehicle. There are also some really interesting insights that are coming about how we need to organize. Do we take robotic vehicles and replace manned vehicles with them? Or do we have robotic vehicle organizations that then can be task organized in support of manned formations? That last description is what the unit has said is the best solution. Don't replace manned vehicles one-for-one with robots yet, but instead have robotic combat vehicle platoons that can come in and be task organized as appropriate for the mission. A number of other insights coming out related to whether the operators of robotic combat vehicles need to be a particular MOS or whether it can be something that's done with an ASI. But in any case, all of those insights are coming to form a body of knowledge that's being used to map out the way forward for robotic combat vehicles within the Army. I will say, what we've done recently at Fort Hood is the largest ground robotics experiment that's certainly ever been done in the U.S. Army. And as far as Corey Wallace is tracking, the largest has been done in the world. So really, we don't talk about it a lot. We're not putting it out in the press for pretty obvious reasons, but we're learning a ton, and we're experimenting heavily in ground robotics. And I think you'd be really impressed with the progress we're making. Down on the lower left is a vehicle that you'll see models of out in the hallway, and you'll see at AUSA. That's the Mobile Protected Firepower. That's kind of a mouthful too in terms of a name. It's going to get a proper name during the AUSA convention here in about a month. So pretty soon we're going to be able to describe it as something other than MPF. But Mobile Protected Firepower is what that vehicle brings to our light formations. The ability to do more than deploy to defend. The ability to go on the offense and break through with a large caliber, precision, direct fire weapon system to break through enemy obstacles, strong points, and destroy light armored vehicles as needed. This is going to be a really significant added capability to our IVCTs and to the light divisions. Right now, the Army's deciding how to move forward in terms of the organizational structure for MPFs, in terms of consolidating them at a battalion level that would then be assigned to light divisions. But the first unit equipped for those mobile protected firepowers is going to be one company set of 14 vehicles that goes to the 82nd Airborne, and it'll go through initial operational tests and evaluation in fiscal year 25. General Dynamics has won the contract for that, so they've actually started production on those vehicles now. It just takes a little while to get those 14 early production vehicles off the assembly line. They've started buying all the pieces parts to do that, and so pretty soon at a motor pool at Fort Bragg near you, we'll see mobile protected firepower. It's going to be a great capability for the infantry brigade combat teams. A couple capabilities to mention on that: 105 millimeter gun, 7.62 coax machine gun, 50 caliber commander's weapon station. It's got multiple smoke grenade launchers. It's got driver's thermal viewers. It's got a commander's independent viewer as well. So it's got the capabilities that are very similar to Abrams in terms of weapon systems and optics. It's just in a much lighter platform. And then on the far right, the AMPV. I don't know if we have anybody from 2nd Brigade, 3rd ID here, but cool. So you guys, were you from 369?
I was 367, sir, but
okay.
They were testing it right alongside us.
Yeah, so 2nd Brigade, 3rd ID, so the Spartan Brigade recently conducted the initial operational test and evaluation for the replacement of the 113, known as the AMP-V. Also kind of a mouthful, so I think that's going to get a name at AUSA, so we're going to be able to call it something other than AMP-V. But 5 variants of that vehicle: one a general purpose, a GP variant, one is a mortar carrier, one is a mission command variant, and then 2 medical variants, one for medical evacuation and one for medical treatment. Awesome vehicle. It might not be sexy, but it's tough, and it's a hell of a lot better than our 113 family of vehicles that have been around since the 1960s. It's going to be a significant enhancement to our armored brigade combat teams. You know, we'll get about 130 of them in each of our ABCTs, so it's a huge investment by the Army. So it's going to take a while to clear out the M113s, but for the ABCTs that get these, it's going to really transform how we're able to maneuver, how potentially we're able to disperse our command posts, how we're able to operate in a LISCO battlefield is going to be greatly enhanced by the AMPV. And it's going to hugely reduce the maintenance burden that our sustainers are currently struggling with our 113 family of vehicles. A couple other things that I'll mention. All of these systems, and when we look at how we need to fight LISCO, all of these systems, along with our fires capabilities and the sensors that are informing our warfighters, need to get connected together some way. In order to achieve that speed of decision, the ability to overmatch our adversary and decide to act sooner than they do, requires some system. It's not going to happen by magic. The system that we're working on for that is called Firestorm. Firestorm links disparate sensors with disparate shooters, whether they're direct or indirect fire shooters, or potentially non-lethal effects shooters as well. Firestorm is a system, you can think of it sort of as a target broker that brings in this information and then finds the best shooter that's matched to the best target. And so it's a potentially game-changing capability that we're experimenting with out at Project Convergence. We've been experimenting with it for a number of years now, and it's shown great promise. This year we're integrating our allies and partners in this. We've got our Australian brothers that are going to be out there in the dust and the heat in NTC with General Taylor's team, and our UK partners are going to be out there. It's going to be really a significant event. Project Convergence, where we put these systems through their paces. In our case, Firestorm and a number of other ones are going to be really important moving forward. They're going to bring together a mission command network in a way to allow commanders to make decisions faster and better match the right shooters with the right targets. Go to the last slide. I'll just talk through, if you're interested in a timeline, this chart lays out sort of when these things are going to start arriving in motor pools and formations near us. So the first one is the robotic combat vehicle. Those systems are going into 1.7 cab this spring, and we're going to continue to iterate and experiment with those, and then we'll continue to move that forward into a program of record in a final variant. Optionally manned fighting vehicle, those proposals are coming in this winter. We'll go through a source selection, and we'll make the down select. The Army senior leaders will make a down select decision in the spring, and then those three variants of prototypes. Will start coming out shortly thereafter in the next year or so. Mobile protected firepower. The prototypes are starting to be built now, and we'll see those for that initial operational test evaluation in fiscal year 25. In AMP, as mentioned, that's being fielded at Fort Stewart effectively now. And the intent is to get those into the brigade combat teams at a pace that's affordable, ideally at a pace of about a brigade a year, but that's all based on the resources that are allocated for the effort. But a great capability that's starting to come to the ABCTs now. Then you see on there a line for next generation main battle tank. We've got an effort underway with the maneuver seated here, PEO Ground Combat Systems, the Ground Vehicle Systems Center, TARDEC, as it used to be known, up in Warren, Michigan, and some industry partners to take a hard look at what's happened in Nagorno-Karabakh and in Ukraine to assess the path that we're on with our main battle tank evolution and ensure that we're on the right path moving forward. There are a number of options for the direction we can go as we continue to either transform Abrams or come up with a new main battle tank. But the key is to make sure that we're solving the right problems. And so that's what we're doing collaboratively with this team that's looking at the threat, looking at the environment, looking at the capabilities we're going to need in order to make the right science and technology decisions and the right investment decisions moving forward on that important platform. Because just as the chief said, the armored forces aren't going anywhere. And I think he meant that to mean that we're going to have armored forces here to stay as part of our armored brigade combat teams are going to be an integral part of any Army operations going forward. And certainly the offensive actions in the last week or so in Ukraine show the power of having competent and capable armored formations that can break through enemy defenses and seize key terrain and then retain that terrain. And the majority of those are mounted in armored vehicles, and that's paying dividends for our Ukrainian partners. So that's what we're up to in the next generation combat vehicle cross-functional team. I want to take a few minutes to lay that out for you, but most importantly, I wanted to hear what questions are on your mind and answer them to the best of my ability. So I don't know that we have microphones out there. I can actually hand this microphone to whoever has a question so the folks in the outstations can hear. But Dan, I'll hand this off to you, sir. And Dan will help us out here.
Like the lapel mic, sir.
Sir, Captain Solero, MCCE. Is there a CBurn variant of the AMP-V that we can expect to get the Stryker CBurn vehicles out of the Navy CT?
Currently, there's not a CBurn variant for the AMP-V, but as we get the AMP-V fielded, the intent is to determine what other capabilities may be needed. There are MI systems and EW systems that we think could be best hosted on the AMP-V. CBurn vehicles or NBC reconnaissance vehicles, capabilities that could go on AMP-V, but currently there is not a plan to put that capability on the AMP-V as part of the initial fielding. Thanks, good question.
Sir, I'm Captain Bruce James. I'm an MCCE student. I previously served as a platoon leader in XO and 1st Armored Division, so I have experience with Bradley. Based on what my peers have said about IVCTs, they don't do logistics or maintenance in any discernible way, similar to how ABCTs and SBCTs do. How do you see the MPF changing the way that we structure IVCTs, and is that part of your mission with the next generation combat vehicle?
So it's a great question and an absolutely essential question to be answered. And so the team here at Fort Benning, there's a Army Capabilities Manager, the ACM for IVCT, is looking at that in particular. They look at what doctrine needs to change for the IVCT that would include the sustainment that's necessary for that vehicle. What organizational structure needs to be evolved to accommodate the maintenance or the sustainment of MPF. They're looking at what training might be necessary for mechanics that are going to be operating that vehicle, et cetera, et cetera. So the short answer is yes, it's being looked at, and it is a really important aspect of how effective MPF is going to be in the infantry brigade combat teams. There are a couple things about MPF that I should mention, though. And the challenge that you described is one of the ones that was sort of front and center in the analysis going in. And so the assessment was, or the question was, how can we get this direct fire capability for infantry brigade combat teams? Can we provide it with Bradleys? Could we provide it with Stryker MGSs? Could we provide it by task organizing with tanks, with Abrams tanks? And the assessment across the board was all of those other options were suboptimal compared to MPF. And so the MPF was designed to have a silent watch capability to reduce its fuel demand. It's designed to be relatively lightweight as compared to Bradley or an Abrams tank. And it's designed to have a high degree of reliability, so the maintenance burden on it won't be as high as might be for other systems. So the point about sustainment and the burden that it places on infantry brigade combat team is a really important question that the team is working through now. So we've got a little bit of time to buff off any of the rough edges on that. So that's really the focus of the effort between now and 2025 when the first unit is equipped. Good question.
So when we were captains together at the advanced course, we came in and got a great brief about this thing called FCS. And it's going to be awesome, and it's going to have a lot of these same family vehicles. It's all going to be based on the network. Obviously, we're not captains anymore, and we didn't get FCS. A lot of things happen. What lessons are you taking from that developmental cycle, and how are we going to avoid the same mistakes, if that's the right term, or the same challenges?
Sounds good. And that's a really important question because we really don't have the time or the resources to make the same mistakes that we made with FCS. And there were a lot of really smart and patriotic Americans who worked on FCS. So if anybody here was part of FCS, Please don't take any of these comments as a criticism of those efforts. But when it was all said and done, it didn't deliver, and we weren't able to go forward with it. So there is a mountain of material on AARs and lessons learned from FCS that we've gone to school on to make sure that we're not repeating some of those mistakes and challenges. And I'll highlight a couple of them that I think are relevant to this. First and foremost, we have to ensure that what we're delivering through these modernization solutions are relevant to the battlefield that we're seeing today and the one that's going to be in the future. So if we can't answer right now that the things that we're developing could survive today in Ukraine or would survive in Nagorno-Karabakh, then we need to pivot away from them. We can say that with all of the systems that we're working on, that these solutions will work in the environments that are going to be relevant in the future. Two, we can't develop a concept of the operation and systems to support operations for that concept that are based on science fiction or technology that doesn't exist. And that's probably the principal takeaway, is that we have to be realistic with ourselves about what technology is going to deliver, on what timeline, and at what cost. And for those who work in this requirements community space in science and technology and industry, you hear the term of unobtainium, a magic material that's out there that's promised that's actually unobtainable, but certainly would be great. This magic new metal composite armor that, weighs less than aluminum, but is stronger than steel. That simply doesn't exist. So we have to make sure that we don't do the things that were done with FCS that required exquisite materials or novel inventions that just aren't going to happen in time. And then one of the other challenges that we have that we learned from FCS is the importance of maintaining our priorities and being true to the priorities that were set, those 6 priorities that were laid out previously. And as we have previously changed our mind and pivoted from one priority to the next, we lose momentum in areas, and that's been really counterproductive. So those are some of the things that we've taken away from FCS that we're bound and determined not to repeat moving forward. But I'd also be remiss if I didn't mention that some of the things that were in their infancy during the FCS program have now been matured over time and are now actually no longer unobtainable, and they're now becoming closer to reality, or will be reality, through some of these modernization efforts. So over the course of time, some folks that have been working at the labs and centers have continued to work on things that were envisioned with FCS that weren't feasible at the time, that are feasible today and moving forward. So that's pretty exciting too.
Jeff, thanks for laying that out. One of your icons there, I don't know if my eyes are filming, but it looked like there might be a tethered UAS. At one point in the strike community, we were talking about telescopic LRASs, but protection but give increased range, at least in terms of identification. Are we thinking about for the RCV or any of the platforms as a component of the end item, a tethered UAS that not only passes information rearward, but can designate for the direct fire system or rearward indirect fire system?
Sure, absolutely. And all the RCV lights that we had in the mediums out at the Soldier Operational Experiment at Fort Hood had tethered UASs. And that was a really significant enhancement in capability. The ability to be on station with multiple payloads was significant. So they can conduct retrans, they can identify targets, they can, in the future, designate targets. A number of the things that you mentioned are much more feasible with a tethered UAS than an untethered UAS. Certainly moving in the offense is a little more challenging with the tethered UAS, but the troopers of Black Hawk Troop 17 figured out how to launch them, how to recover them, and move out. And so them being tethered wasn't a significant impediment over the untethered option. Having a mast-mounted sight would be great, but those are relatively heavy and take up a lot of space and require a lot of power relative to the tethered UAS. So I think that that's the path we're on right now. But frankly, one of the challenges with tethered or untethered UAS is the acoustic signature. And so because we had a live OPFOR out there, a challenging and determined OPFOR, they figured out how to identify UASs using their ears. And so that's something that we'll work on going forward, is making sure that we account for acoustic signature management with the UASs that we're deploying. But a great capability and something that we're going to use going forward.
Okay, so just, I think you touched on it when you were talking about the robotic combat vehicle SOE2. And Corey was kind enough to send through some of the daily spot reps and the playbook, which was really useful. One of the insights that I thought was interesting from the soldier feedback was the idea that for the future employment of RCVs, rather than having them as bolt-on capabilities or add-in capabilities to existing structures, that we potentially need to rethink about how we actually structure platoons, companies and battalions around RCV capabilities in some circumstances. Can you give us some early insights about how you think future platoons, companies and battalions may be structured, where the RCV may become that central component as opposed to a bolt-on capability?
Yeah, it's a great point. And so that was one of the important insights that we wanted to gain from the unit, is how did they want to see RCVs integrated into their formation? Did they want to replace their Bradley cavalry fighting vehicles with a RCV medium, or a combination of mediums and lights, and do a combination of manned and robotic vehicles in the same platoon? And in most instances, that was not the preferred option. And what the unit and the soldier feedback looked like was, we believe that the robotic combat vehicle units are going to have a particular skill set that's going to require a competence that means they need to be an organic unit that's made up of robotic combat vehicles, maybe of different flavors, and then the control vehicles associated with those. So that is at the platoon level. And then if need be, that platoon can be task organized at the section level to go support manned to unmanned teams with habitually organized manned units. So a manned scout platoon, a manned tank platoon. They would integrate a robotic section, but that robotic section is not always part of that tank platoon, or not always part of that scout platoon. That's generally the feedback that we got from folks on that. And it largely has to do with the anticipated maintenance expertise that's going to be needed to work on the robotic vehicles, and the necessary skills and behaviors for the robotic vehicle operators. That's probably best served and best accomplished, both those tasks, by folks who are specialists in that skill area, as opposed to folks who are specialists in their manned vehicle and then just on the side happen to know the menu options for the robotic vehicles.
Hi, good morning, sir. I'm Captain Caston from MWFC. The question that I have for you, sir, is that with the introduction of robotic vehicles and the rest of the NGCV family, what capabilities does the CFT pursue when it comes to minimizing the EW signature or the EW offset for the vehicles?
Yeah, that's a great question. And that's one of the things that every unit going through a NTC rotation or a CTC rotation like JRTC or JMRC is coached on, is that electromagnetic, perhaps you can understand. Thank you. Good question. The electromagnetic signature coming off of command posts is enormous, but the electromagnetic signature coming off of our vehicles is significant too. And so that's something that we have to be cognizant of. You know, initially some of the robotic systems are using sensors and sensing modalities that transmit. Whether they transmit, they transmit energy somewhere along the EM spectrum, and adversaries could pick that up. And so that's one of the things we're looking at very hard as we transition to robotic vehicles. How are they sensing their environment in a way that they can't be detected? Similarly, how are they communicating with control vehicles or with a mission command system in a way that is robust and can't be jammed by an adversary? Part of that has to do with having redundant modes, so a pace plan essentially. But right now, those are some of the main challenges that we're working through. How do we make sure that the systems we develop are operationally relevant and don't paint a huge electromagnetic signature on the battlefield and reveal where our forces are? I feel like I'm at a funeral here. Everybody's so sad. This is day one of the maneuver conference. We had the chief and the SMA and the Second Army. That was an awesome morning so far.
Sir, Command Sergeant Major Hardy out of Fort Riley.
Good to see you, Sergeant Major.
Good to see you as well, sir.
Cool.
Sir, my question is, with the addition of robotics and they come into the ABCTs, are we going to need additional infrastructure to support the robotics, or are we going to still be able to support with the current infrastructure we have now? The base space is always a premium with our tanks, so we're going to need to have more stuff for that.
So we don't know yet. The intent for RCVs is for them not to put additional burdens or demands on your infrastructure beyond what you would already have. So not additional heavy lift, not additional exquisite maintenance capabilities. But frankly, we don't know yet because we haven't settled on the final solutions. What you saw up there were prototypes and representative samples of some of the leading innovators that are working on robotic combat vehicles, the light variant and the medium variant. And I think once we settle on what the final versions are going to be, then we'll have a good sense for what the full domino PFB implications to include facilities are going to be. But right now, for 1/7 CAF, working through the motor pool space and the infrastructure requirements is one of the things that we're hammering on right now at Fort Hood. But right now, it doesn't seem to be something that is insurmountable, but it's something we'll watch closely.
So we probably have time for one more question, and that'll reserve a few minutes for your closing comments.
Hello, sir. My name is Special Spec. I'm from 116 here on post, and I'm just curious, as we come out with RCVs, that's going to take a lot of new skill sets that soldiers are going to need to learn. Do you have any advice for soldiers who might want to potentially participate in these types of things in the future?
Yeah, we definitely want to tap into your interest and your experience. So recently, we were out at a virtual experiment at Aberdeen, and it was interesting to see the soldiers and the leaders who were in the back of robotic combat vehicle control vehicles working their screens. And when we went to the AR, we asked them afterwards how many of them were gamers. And the majority of them raised their hand and said they were gamers. But even for those who weren't gamers, they were competent and they were really effective at working the systems. I say all that to mean, even if you're not a gamer, you can be successful working in this new space. But what we're doing is we're executing a bunch of virtual experiments, soldier touch points, and soldier operational experiments like the one I just described at Fort Hood, where soldiers from units in the field are being put in prototypes and being put in situations where they're able to provide the feedback, learn the systems, and then provide the feedback. And so that's done normally with units from Force Com. So we're hitting up mech infantry platoons, tank platoons, scout platoons, and then there'll be opportunities here at the Maneuver Battle Lab where we'll do the same thing and hopefully tap into some talent from 116 here at Fort Benning, we can get you in there and leverage your expertise as well. So if you swing by afterwards, we'll get your info and see how we might be able to get you lined up. So, all right. Well, listen, this is an exciting time for modernization in the Army. We've got some exciting priorities that we're working on for the next generation of combat vehicles. It's a plural, not a singular. So whether it's the AMP-V, the AMPV, robotic combat vehicles, mobile protected firepower, or the next generation main battle tank, know that your Army is innovating and moving forward to replace legacy vehicles that have served us well, but are now past their prime. So we look forward to working with you moving forward and appreciate any input and feedback you might have for things that we ought to do going forward.